share my screen. Okay. So, welcome to week 5, everyone. This is the last lecture I will be giving for this course, for this session. So if you made it here today, congratulations. You're at the end. You're kind of at the end of this course. You're at the finish line. There's just a couple more things that we're going to teach you today, and you should be all set. Again, for your final, it'll be due next week at midnight Eastern time on Monday. I forget the exact date. It'll be due the 13th, right? So Monday the 13th at 11:59 p.m. Eastern time. So it's slightly different from the typical due date because it's normally due right before class, but for the final, since there is no week 6 class, it'll just be due at midnight. So yeah, there'll be plenty of time for you to ask about the final in a little bit, but before we go over that, I just kind of want to give you a little bit more information, kind of building off of what you all learned from last week. So we talked a lot about, how printers print, how to design things, just around the 3D printer limitations. But now we're going to cover a little bit more nitty-gritty stuff, which is kind of the material science side, because this is also a very important aspect of how you use your 3D printer, and the material can definitely unlock or prevent you from doing certain things. So let's just get into it. Okay, yeah, so like I said earlier, right, there's many different materials that you can choose when it comes to 3D printing. Last week I kind of talked about how the 3D printing industry benefits from, the injection molding industry, which has been around for a lot longer than 3D printing has been. And the nice thing about it is that once 3D printing came around, it was just a matter of time before more and more materials became available. So I'm going to be talking about a couple materials today, but obviously it is not, or these aren't the only materials available to 3D printing. If I spent the time to try to list every material, we'd be here all day, and then I would definitely miss some because new ones come out all the time. But the advantage to this is that you can cater your design to use a certain material based on, the material properties of the material. So, you can design something for strength, flexibility, durability, all of these things with the material in mind. And doing that will kind of allow you to, achieve the goal, or usually achieve the goal of what you're trying to do. And in some ways you can achieve it better with some materials. So I'm just going to talk about a couple of them today. Again, there's a lot more out there, but here are just a couple of materials for you to keep in mind. And I can maybe give some examples for some of them. Okay, so the first one we're going to talk about is something called polylactic acid, which is short for PLA. If you've been around 3D printers, I think it's pretty likely that you've heard of this material. And the main thing about it is that it's very cheap, partially because so many different companies make different PLAs. You have many different colors available, and it's very easy to print. So in terms of the strength, it's not the strongest material, but it's very easy to print, and it holds up to most things for most scenarios. So it's actually a very rigid material compared to some of the ones I'm going to be talking about later, which can be an advantage or disadvantage depending on what you're designing. But yeah, PLA is pretty great. You can see the printing temperatures aren't very high. You know, the nozzle temperature is anywhere from 180 to 230 C, which is, relatively speaking, pretty low. The print bed temperature, which is like the, someone's unmuted. Oh, let's see. But yeah, for relatively speaking, the print bed temperature is pretty low as well. So, you know, we used the slicer yesterday, or I mean, not yesterday, last week on Prusa Slicer. And basically, the print bed temperature is just the temperature you can set for, you know, the build plate. Back in the day, some printers didn't even have print bed print bed heaters, so that's why PLA became so popular. You know, the bed temperature can basically be ambient and it doesn't warp at all. So it's pretty easy to print. I can almost guarantee you almost any printer on the market today is capable of printing PLA, and you know, the vast majority of printed parts will be made of this material. One of the things that's interesting about it is that it's actually a bioplastic, so it's technically biodegradable, but it needs very specific conditions for the material to degrade and break down. So if you leave your print outside, you don't need to worry about it like becoming compost, though it is kind of cool to think that it could do that, but unfortunately it doesn't, or in some cases, fortunately, right? But the main con for this material, or it could be a pro, is that it's very brittle, which also means it's very rigid. So if you need really rigid parts, PLA is pretty good for that. The other con that's not really on here, well, I guess it is when it says lack of mechanical properties. The main one that we're talking about here is it's resistant to deformation with like higher ambient temperatures. So it's not very heat resistant compared to the materials we're going to talk about later. And it's just because, you know, these printing temperatures are all pretty low. And that means it's pretty easy to warp or deform when it gets heated up to, you know, somewhat warm levels. I've had people put printed PLA parts inside of their car, like inside like the cabin, and then on a hot day when the inside of the car kind of bakes, it caused the prints to warp. So if you need something that is subject to higher temperatures, PLA may not be the right choice for you. But for, you know, climate controlled environments like desk toys and stuff like that, PLA is like almost always a perfectly acceptable option. But yeah, that's PLA. It's a very popular material. And yeah. The next material here is ABS. ABS is a very popular material in the injection molding space. If you didn't know, stuff like Lego bricks are all, you know, made of a kind of ABS. So, you know, it's a very widespread material. It's pretty cheap, similar to PLA, just because of all the different options you have. But you can see here, it has some, you know, better mechanical properties in many cases, right? It's a little bit stronger, it's a little bit less rigid, but it can take impacts a little bit more. The print temperatures are a lot higher compared to PLA, and even the bed is higher as well, right? So again, you're going to get better heat resistance with a material like ABS, but that comes at some cons, right? The main issue is that its potential to, or there's a lot more potential for the print to warp when you're printing it, especially if you're printing with an open frame and like an unenclosed printer, and it requires high temperatures, right? It's not super good for you to breathe in if you're like, sitting next to the printer while it's printing ABS, you'll probably find that it smells kind of funny. It's probably not good for you. So, when you want to print ABS, it's a good idea for it to be in a very well ventilated area, just because, ABS is not good for you when it's burning or melting. But, with those more difficult print temperatures and stuff like that, again, you get more temperature resistance, and just in general, ABS is typically a little bit stronger than something like a PLA. It's a little bit more durable. Again, it's a little bit less rigid, but you need to kind of balance these mechanical properties, right? If something is more rigid, it typically becomes more brittle. If it's a little bit softer, it can take a little bit more impact, resist a little bit more before it breaks. And in some cases, you want things to fail, a little bit slower, and a little bit more predictably. That's why you might want to choose something like an ABS, but then also, the temperature resistance. So personally, I print a lot of ABS and another material called ASA. ASA is very, very similar to ABS, but the main advantage to it over ABS is that it's UV resistant. So if you leave an ABS part outside for a good while, it might yellow, or like the color might change a little bit, and the part could get more brittle. And that's just kind of what happens when you expose ABS to a lot of UV light. But, with other materials like ASA, you can get very similar mechanical properties without having to deal with that. ASA is a little bit more expensive, but not like super significantly. So I kind of put them in the same category as an ABS. They just are UV resistant instead. PTG is a cool material as well. I used to print a lot of PTG before I transitioned to ABS. And one of the big reasons is that PTG is a lot easier to print on an open frame. So the printer I have now is fully enclosed, so I don't have any problems printing ABS. But back then I was printing with, open frame machines, and I wanted something that was a little bit more heat tolerant compared to PLA, and a little bit more durable. Because PTG, kind of similar to ABS, it's a little bit more ductile instead of rigid compared to a PLA, so it can kind of take impacts a little bit better, but it can also withstand higher temperatures. You can see these nozzle temperatures and bed temperatures are kind of similar to ABS. They're a little bit lower, but it kind of puts you in an area where it's safe for more applications compared to PLA. I left a PTG part in my car all summer long, and when I came back in the fall, it was completely fine. It worked with no issues, and I was pretty happy about that. I couldn't say the same for like PLA parts when it's subject to those kinds of conditions. So that's kind of why I preferred PTG for a very long time until I switched to ABS. But yeah, it's a pretty great material. One of the big cons to PTG is that it's very susceptible to moisture. So you need to make sure you dry your material, especially if you're in a humid environment, because the material will absorb moisture, and then when you print it, the moisture inside the filament will kind of boil out of the nozzle, right? These nozzles are pretty hot now, over 200 C. That's like, double the boiling point of water or more. So it'll boil pretty quickly, and then it'll make your surface finish, or the surface finish on your prints worse. It'll also make them weaker because you'll introduce, little pockets of air bubbles as the water is evaporating. So you really don't want that. So you want to make sure you dry your filament really well. And this is the case for not only PTG, but a lot of other filaments that I'm going to be mentioning here. You'll kind of notice that some of the more specialized filaments tend to be very hygroscopic, right, or susceptible to moisture. So when you print these materials, it's a pretty good idea to either dry them before you print them or even continue to dry them while it's printing. The other thing about PTG is it doesn't warp as much as ABS, so that's nice. The only thing is that it's a little bit more stringy compared to PLA and ABS, which also kind of goes back to the moisture thing. If your filament is really wet and not dry, it'll kind of boil out and string around your print, which you might have to clean up later, and it's slightly less ideal. So, dry your PTG, dial in your print settings, and typically, it's pretty easy to print. But yeah, that's PTG. Next on the list is TPU, which is, in my opinion, one of the most unique materials on this list. And the reason for it is that it's a very, very flexible filament. So if you ever got to see PTG or TPU as a, in its role of filament before you print it, you could take the filament and like bend it as much as you want without it breaking at all. It's almost like it's almost similar to like a wet noodle, like a piece of spaghetti that's been cooked. So it's very flexible, and it doesn't really break. So I printed a benchy out of TPU, right? If you remember the benchy from last week, I printed one out of TPU, and my roommate at the time, his way of testing all the materials that I printed was throw the benchy on the ground as hard as possible. It's probably not the most scientific process, but the TPU benchy was the only one that passed, because every print that he threw on the ground would explode into many, many pieces and would shoot all over the room. But TPU just kind of bounced off the floor, and it made him very confused. But yeah, TPU is pretty great. It's a very interesting material, and it's also really interesting when you combine it with other materials. So lots of printers now are starting to come with like multi-material capabilities, which will allow you to print both rigid and soft materials in the same part, right? So you can now control like what section of your print is flexible and what is rigid. And when you do that, you can get really interesting behaviors out of the single parts that you print, right? So you can reduce your part count for your designs, and they're pretty unique. So I've seen people print like one-piece hinges, right? So there's like a section in the middle that's TPU with like a PTG or an ABS rigid part around it, and so it makes the center part flexible, with the other outer parts nice and rigid for mounting the things. So TPU is pretty awesome. I think it's really cool. The main con is that because it's so flexible, you typically have to slow your machine down, so the filament doesn't get tangled inside the extruder. But in the grand scheme of things, I think it's totally worth it. It's pretty awesome. Okay, so nylon is kind of where we're transitioning away from, more consumer materials into what I kind of consider more engineering grade stuff. Engineering grade materials are usually a lot harder to print compared to the ones that we've talked about earlier, but that usually comes with the benefit of better mechanical properties, right? So nylon is a very strong material. You can see these nozzle temperatures are also pretty high, along with the bed temperatures. When I print nylon, I actually print even hotter. So I print at 285 C. So these materials are a little bit more demanding on the hot end in your 3D printer, and almost always recommend printing with enclosures, right? So because these prints print at such high temperatures, you want to make sure the ambient temperature is also high, because if it's too low, then the printer or as the filament cools down, it'll shrink a lot. And when that happens, it'll warp. So if you print nylon or try to print nylon on an open frame, it'll typically be pretty difficult because it'll have a tendency to warp. But if you have an enclosed machine, it'll allow the ambient temperature around your part to be higher, and it reduces the chances of warping. Overall, nylon is a little bit more difficult to print. Some consumer printers can print this, but it's typically a little bit more challenge. It requires a little bit more setup. One of the things that it's very susceptible to is moisture, similar to PTG, but nylon's extremely susceptible to moisture to the point where you need to print almost exclusively out of some kind of dryer to prevent the filament from getting wet. It can absorb moisture like within the matter of like hours, so you need to make sure it's really dry before you print it. One of the things you'll also see when it comes to materials like this is they'll add carbon fiber or like chopped carbon fibers in in certain engineering materials. They do it with some PLAs, PTGs, and ABSs, but you really see the benefit when it comes to these engineering grade materials. So again, nylon's very prone to warping, but when you add some kind of carbon fiber into the filament, it actually makes it easier to print. So a carbon fiber material or carbon fiber filament is a lot more rigid, and it warps a lot less compared to its natural counterpart. And a lot of the times when you're printing engineering materials, you're looking for added rigidity anyways. So a lot of people will print something like CF nylon, right? Or it'll be like labeled as like PA6 or something like that. There's a lot of different nylons out there. There's different amounts of carbon fiber in the nylon, just depending on what kind of nylon you buy. It can get, a little complicated, but you can get very different mechanical properties out of it. So nylon's pretty awesome. I guess the most recent use case I've had for it, I was fixing my car over the weekend, and I was changing the coolant out of the radiator, and the drain bolt was plastic. And when I screwed the drain bolt back in, I accidentally broke the head off, and my car started leaking coolant from the drain hole. So I took the old broken bolt out that I snapped, which is definitely my fault. I took some measurements and I 3D printed a carbon fiber nylon drain bolt, and then I screwed it on, and now my car works again, right? It took me to work, and it's been good ever since, no leaks. So it's pretty awesome that you can do that with 3D printing these days. The reason why I chose nylon for this application was mainly because of its temperature resistance, right? So I wanted it to be able to withstand the high temperatures inside the engine bay, and it's touching the coolant in the car, so it definitely needs to be resistant to high temperatures. So I just went with nylon, and the car is perfectly happy. So that's one pretty cool use case, and that was pretty recent for me too. So those are some of the things you can do with 3D printing now, which is cool. Polycarbonate is pretty awesome as well. If you didn't know, polycarbonate is a material that people often use when they make bulletproof glass. So, if it can stop a bullet, it's, probably pretty strong, and it is. And the cool thing is you can 3D print polycarbonate. Again, it's in the engineering grade category for me, so it's typically a lot more difficult to print when it comes to, or when you're comparing it to the other consumer grade materials. You can see the print nozzle temperature recommendations are pretty high, above 300 Celsius in some cases. and a lot of printers out on the market can't reach those temperatures. So, it's pretty hard to print this stuff. It's very, very prone to warping, like other engineering materials, susceptible to moisture, just like nylon. So, it's a pretty hard material to print. But at the end of the day, if you need something super strong, right, polycarbonate is a pretty awesome material. But yeah. Okay, yeah. So here's a little chart with, an overlay of all the different materials. And you can kind of see where some of the materials shine, right? TPU is a lot more flexible, while some of the other parts are a lot more strong or durable. So this just kind of shows you that you have so many options when it comes to material, and that can definitely affect how you design things. So it's a good thing to keep in mind. But for small stuff, PLA, PTG, or even ABS is usually more than enough. But when you're doing some projects that might require a lot more strength or some flexibility, picking a more specialized material can sometimes be a really good choice for your design. Does have any? Wow, I can't talk today. Does anyone have any questions about this? I know it's a lot of just material, or just me yapping about material properties. So I'm happy to answer any questions. No questions? Okay.
If you have to like remove some excess material, do you reuse that?
Ooh, okay, that's a good question. So I guess going back to last week, I'm guessing you're talking about like the supports and stuff, right?
Yeah.
Yeah, so in most cases, the supports are sacrificial in the sense where you'll print the material, you'll take it off, and then you'll just kind of throw it away. There are some services in places like Europe which allow you to recycle, you know, either like discarded prints or supports like that. But for the most part, recycling filament is not something that has been adopted super widely yet. The main, I would say the main reason is because it takes a lot of effort to recycle a material properly. You need to make sure the material is clean and not like dusty, and then not contaminated with other materials as well. So, there's not a whole lot of incentive, especially because you can just buy a new spool for like 20 bucks and just print more stuff. So, unfortunately, that's not really the case right now, but things are starting to change a little bit. I actually did just buy a filament recycler, which I'm kind of excited about. But this is like the first one that's come available, like to the commercial market or the consumer market. So I'm curious to see where this goes. But right now, it's not a very big thing.
Also, is it, can you like alternate between different materials if you want to make the supports a different kind, like a cheaper kind? Is that okay, or is it too complicated, like too much effort?
Yes, so that's actually a very good question as well. One of the things that people have been doing recently, especially with machines that can print with multiple materials, is they'll mix different materials for their model and their support material. So for example, PTG and PLA don't really stick very well together. So what people will do is they'll print their model, out of one material, like for example PLA, and then they'll print the support material out of PTG, right? So when they do that and you take the print off, because they don't stick together very well, the supports just kind of fall off, which is very convenient. So having that kind of multi-material capability is, I think, something that is becoming a little bit more common. in the past, some people would use specific support filament out of PVA, which is basically the same kind of material you'll find in like a glue stick. So people will print a very complex model with one material and then the supports out of PVA, and then they'll soak the model in like warm water afterwards, and the supports will just like dissolve off. So, there is mixing of materials in some niche cases. It's becoming a little bit more common, but yeah, it's not super common. But some materials, or a lot of machines have multi-material capabilities, so people are trying that now. Did that answer your question?
Yeah, thank you.
Yeah, those were both really great questions. So, yeah, thank you for asking them.
Question.
Yeah.
In terms of subtractive manufacturing, when using multiple filaments, what are the main methods you would recommend? Are there different combinations that work better? Or in terms of when you need to subtract material, but there's multiple different materials being used?
What do you mean by like subtractive manufacturing? Because, I mean, most of the stuff I've been talking about here is like 3D printing related, which is additive. But for subtractive
Mhm.
manufacturing, are you saying like if you're machining something that has like two different materials, how do you approach that?
Yes. Yeah.
I mean, I would say for the most part, like subtractive manufacturing is pretty heavy duty in many cases. So, if you have a milling machine, you'll probably have, some kind of high speed steel or like carbide end mill. And those things usually are a lot stronger and a lot harder than the thing you're cutting. So, like, if you're cutting a piece that is like half metal and half plastic, that end mill probably won't really care. If you're drilling holes through stuff that is multiple materials, the drill bit probably won't care too much either. If that's what you're asking.
Yeah, I just kind of was wondering about if you had any experience with having to use subtractive manufacturing techniques when working with like plastic filaments when printing things. Like if a print comes out not exactly how you want it and you're running out of material, that kind of thing.
Yeah, well, in some cases, you know, let's say I printed something with a hole in it and, I didn't account for the correct tolerances. Sometimes you can run through the hole with like a drill bit or something and just kind of fix it. So that's definitely an option as well. I mean, most of these materials are just kind of some kind of plastic. So most like hand tools and stuff like that are, you know, definitely pretty easy to work with. A lot of people print like cosplay stuff or like replicas of things. They'll 3D print helmets for, Star Wars or something. A lot of the times you'll see people sanding the parts and stuff before painting them for like better surface finish. So you can definitely use like subtractive methods on 3D printed parts. It's not very uncommon. For my applications, the stuff I make is, I am a 3D printer enthusiast, so I 3D print parts to make other 3D printers. So a lot of the times, I'm just printing the part and then, putting it on another printer or like using it as, a motor mount for another printer. So I typically don't use subtractive processes. But, if I'm making something to be painted, or, you know, I maybe messed up some tolerance. Like drilling or sanding is definitely not out of the question.
Yeah, at my work I utilize 3D printers and subtractive and additive manufacturing techniques as well as painting. So we our industry standard calls for specific types of materials, not all of which are listed, which is
Sure.
why I was wondering about these ones in specific if there were any tips or methods that you knew of that worked better with those ones in the future if I end up having to work with those. That's why I asked that. You answered my question though, so I appreciate it.
Yeah, no problem. I guess like the other thing to keep in mind is if you're gonna glue parts together, you just want to make sure like the adhesive you're using is compatible with the right material. Because sometimes, you know, the adhesive doesn't work well with the material you're using. So if you're joining parts together, check the adhesive. Another thing people do is they'll like kind of seam weld parts together with like a soldering iron. They'll take two parts and they'll like melt the ends to kind of fuse them together. But yeah, there's many methods of post-processing certain parts. I guess one side note is that if you're using like a carbon fiber material or a carbon fiber infused material, it's probably a good idea to wear like gloves and some kind of respirator when you're processing the material if you're going to sand it or something, because you're going to be sanding a part and then you're going to get like small carbon fiber particles floating around in the air. You probably don't want that going in your skin or your lungs. So if you're
Yeah.
processing materials like that, definitely do it in a good environment and wear the proper safety safety materials are for your body.
Yeah, we have standard operating procedures for a lot of these materials, especially the ones that require additional machining. Like carbon fiber, I've only done one project or task, you could say, working with carbon fiber, and yeah, there's definitely safety precautions that we have to take when doing that kind of stuff. But I've never worked with like just listing specific materials. Like I've only done minimal work with TPU filaments. I've seen it done, but I haven't worked with that kind of more flexible material before. So I was just curious about how those things react with that kind of manufacturing process.
Yeah, it's all pretty cool stuff. And most of these things are pretty safe besides like the carbon fiber stuff. So, as long as you're being careful, maybe don't melt stuff right in your face. Maybe wear some kind of mask or something.
Yeah, of
But for the
course not.
most part, this stuff is, you know, pretty safe to handle. But yeah, that's pretty cool. Thank you for sharing.
Yeah, absolutely.
Any other questions or comments about 3D printer materials? I wish I wasn't at work right now because I could show you some samples, but I don't have any. Okay. Well, again, if anyone has any questions, they're welcome to add them into the chat or whatever, or I'm happy to answer them after class. But I guess with that, we can move on with kind of the next section, if it'll let me advance the slide. Oh, okay, yeah, I forgot about this slide. In terms of 3D printing resources, I know a lot of you are gone for the summer, including myself. But at Purdue, there's many different places you can get things printed. I'm not sure if all these links still work because this slide is a little bit on the older side. But there are many, resources available to you at Purdue to get things printed. So if, you know, for some specific majors, they have like 3D printing labs like the ME print shop. But there's also, things available to everyone. Like the 3D printer club at Purdue, I'm pretty sure they print stuff for other people, which is pretty awesome. And I'm sure you might know someone with a 3D printer. Well, if you're watching this video or you're here today in class, you do know someone now because that person is me. So I have a 3D printer. So, if anyone needs stuff printed, a lot of people at Purdue in these, in these clubs or in these resources are available to you, or people that you know, like me. They're almost always happy to print stuff for people. So, yeah, there's definitely many resources out there for you to if you're looking to print stuff. But yeah,
Andrew.
yeah,
So I'm just curious. When you're at Purdue, do you live off campus? Because I'm wondering about regulations in terms of 3D printers for on-campus residence halls and stuff like that. Because I'm looking to upgrade to a Bamboo Lab printer, which is a lot higher, requires a higher voltage of electricity. So I'm curious as to if you know those regulations off the top of your head.
sure. This is actually a funny topic because when I was at Purdue on campus a couple years ago, it wasn't as regulated. But I think if you're living in a residence hall now, I'm pretty sure they don't allow 3D printers in your dorms.
Yeah.
And I think the main reason is because it's technically a fire hazard because it's, it's a exposed heating element that's like melting stuff. That's also potentially creating fumes that aren't good for you. So pretty sure that's why Purdue doesn't allow them in residence halls. But if it's off campus, it's usually pretty fair game. So I'm off campus now, so I run my printers in my house. But if you're on campus, you might want to double check like those kinds of like rules because I think they are changing. So yeah,
Yeah, because I knew about the safety risks of like the open print head, but the printer I'm looking at getting is an enclosed bed with
like
fumigation.
an
So
X1 or a
I was
P2
just
or something.
yeah, I was looking at possibly getting an X1 carbon, or depending on if they go on sale, possibly I work with an H2D most of the time at my work, so that's why I was thinking about that one, but that one is of course more expensive and higher end, so I was
Yeah.
just looking at figuring that all out.
Yeah, I'm not exactly sure the rules on like open versus closed frame printers. You might want to check on that. I was under the impression that just all of them aren't allowed, and I think you know you might want to be careful if you're on campus because they may not like it if they catch you.
Yeah,
But yeah,
appreciate it.
yep, no problem. And again, like there's other resources at Purdue, so if you're like looking to get things printed, you can definitely reach out to them or me. I'm definitely happy to print things for people. So
Yeah, I've had my own printer for a while. I'm just looking to not have to wait in a queue is the main thing.
that's
If I
fair.
have to, I don't really care, but it's just another thing I was looking at figuring out.
Yeah, that's fair. Yeah, I have like 3 or 4 printers at my disposal at almost all the time. So in terms of queue, I usually don't have one, but it's kind of because I have a problem and I keep on building printers. But yeah.
Yeah,
Anyways,
that's a great problem to have, man.
yeah, I can
I don't know what you're talking about.
I can definitely send some videos and stuff to everyone later. But it's a pretty
No,
fun hobby.
I'm the same way with computers. Trust me, it's a problem. It's a
Yeah,
problem I know I'll do well.
yeah, but it's a fun problem. But yes, sorry, I'm getting sidetracked. If you get me talking about 3D printers, I'm just not gonna stop. So I'm gonna try to get things back into
Apologies.
focus. No, no, it's okay. Today's a pretty short class because there's no demo. But yeah. Anyways, kind of going back to our class, the last thing that we're looking to do here is to render your final project. So, you know, if you ever look at commercials and stuff like that, if you don't have an ad blocker or something, a lot of the times you'll see some kind of product like floating across the screen or something. You might see like a car driving across the street or something. A lot of the times it's not actually real. In many cases, it's a rendering of the product that they're trying to sell. So what we're going to teach you how to do is render your final projects. If you don't have your final finish today, that's fine because we're gonna do two separate rendering assignments. We're gonna do one in class right now, and then either after that or after this class finishes, you're going to create a second render for your final project. We're not going to be animating the renderings, unfortunately. It's just going to be a still image. But these renderings can be pretty useful for other purposes, like if you're presenting your work to someone, or some kind of either someone or some company. You might want your design parts to look more professional, and rendering is one way to do that, right? They come out looking super nice, and looks super professional. So we're going to teach you how to do that today, and that's basically the last thing that you need to know to finish this course. So yeah. Again, your final project, which I talked about briefly before we started, is due next week, right? On Monday at midnight Eastern time. It's, if you haven't started yet, these are just the very basic breakdown of what you're going to be making. It's basically make anything, as long as it's not something we did in class. So obviously, don't do the engineering fountain, or like don't do the hair dryer. Like you're going to get 0, and then I'm going to be sad. So just don't do anything that we did in class. But it just has to have at least 5 design features. Again, each design feature is like 1 extrusion or 1 revolve, right? So you need to have at least 5 of those. I encourage you to kind of explore the different design features or techniques. So don't do just all extrudes, right? You can please, like I highly recommend you do, mix it up a little bit. Use some fillets, use some extrusions. You know, I really hope that you don't just do 5 extrudes and call it a day. And this is just a 5 design feature minimum. So again, if you want to do more than that, that is, totally cool, and it's definitely encouraged. I've definitely seen very, very complex design features or complex finals where I'm like, wow, you really spent a lot of time doing that, which I think is totally awesome, and I really like seeing that. The nice thing is, I know everyone or most people are off campus right now, including myself. But when everyone comes back in the fall, I will, give everyone the option of having their final projects being printed. So, if you really like your final and you kind of, want something to show for this class, I'm going to, print all the finals out, and then return them to you. So I want these finals to go really well because I really like delivering really cool finals to you all when the class finishes. So that's kind of why last week I went over, designing for 3D printing, right? So it's definitely keep those things in mind. That's why, the requirement that it must be designed with manufacturability in mind is, part of the requirements for your final. Because it both benefits yourself because you learn more, but then it also benefits me because you give me something that is a lot easier to 3D print, and then it benefits you again because you have a really cool thing that you can keep and it won't like disintegrate when I give it to you. There have been times where people have made really awesome models that I can tell they spent a lot of time making, but then like it made it the design they made was very difficult to print, right? In some cases, some features were too small, or in some cases, every feature was too small. And like, again, for one example, someone designed the Golden Gate Bridge as their final project. Again, it's a very cool project. I really thought the model was awesome. But when we went to print it, especially at the scale, when we made it the right size for the print bed, it was super, super tiny, or all the features were super, super tiny. And whenever we tried to remove it from the print bed, the bridge would just break. And it was really sad because when they came came in to get their final project, it just kind of fell apart in their hands. So I really don't want that to happen to any of you. So, if you're unsure about a certain design choice you may have made, you're more than welcome to send it, either to the general chat or to me personally if don't want to be, like, I guess, critiqued publicly. You're more than welcome to just send me a message, be like, hey, like I made this thing. I'm unsure if I should make any changes to make it more printable. I can definitely give you feedback. Some people have asked me already, and I tried to give the best feedback I can because I want all of these prints to come out nice. So, yeah. Again, I want you to succeed in this course. So, if you have any questions, please just ask me because I'm more than happy to help you out. But yeah, does anyone have any questions? I feel like I've gone over this a good couple times, so I hope that everyone knows what's up.
I have a good question.
Sure.
So I guess if we make different parts and like put them in assembly, does that count? Like does each part, if they have like multiple like features, I don't know, do they kind of count together to make five, or I don't know. I'm just kind of curious.
Okay. I mean, I guess for an example, I think there is one time someone designed like a simple like engine model for like a V8. Like, I guess if your question is like, does each piston count as its own design feature, or like let's say each piston had like 2 design features on it. If you're printing like 5 pistons, that's still 2 design features because you know it's just the same one, but I just printed it more than once. But I feel like when it comes to assemblies, you very like quickly exceed the 5 design feature minimum. So most of the time, like the design feature thing is like not really an issue, if that's what you're wondering.
Okay, yeah.
I'm gonna
Thank you.
say no on like the like if you're printing the same part multiple times, because you're still at the end of the day you've created 2 design features, even though I'm just printing it like more than once. But it's usually not an issue. Any other questions? Oh, okay. One question I get a lot is how big should my model be? So I will say I kind of leave it up to everyone's judgment, just because I know the geometry of the part is very dependent on the thing you're making. So some people make really really tall things like rocket ships. People really love to make rocket ships, like the Saturn V rocket, for example. I think I've gotten like 7 or 8 of them. But in terms of footprint on the build plate, a rocket ship isn't that much, but it's very tall. But then some people print, like someone gave me like a license plate, right? And that takes up a lot of space on the build plate, but it's not very tall. It's a very thin part. So I kind of want to leave it up to you, and in your judgment. I just ask that you please be reasonable, because there's a lot of you. I think there's over 100 people registered for this course, and there's one of me. So I'm going to be printing everything. So please don't give me something completely ginormous for me to print. Even though it's cool, I might have to scale the print down. So I do have the ability to change the size of the model in the slicer. But when I do that, certain features that you may have designed for a certain size may not be that size anymore. So, if there are certain scenarios where you need the part to be a specific size, I would ask that you maybe tell me, because I think one time someone sent me like a toothbrush holder and it was a really, really large part. And then, you know, I scaled it down just for the sake of print time and stuff like that, and then it ended up being like completely useless because they couldn't fit the toothbrush in it, right? So, if you have something that like is kind of like size dependent, just please ask me, or please just tell me. But for the most part, I'm pretty flexible. I usually recommend, something around the size of your hand, if you can help it, is like a good barometer. Because like, don't send me like this giant thing. My printer can print 300 by 300 by 250 millimeters. So technically that's the maximum size I can print, but I typically like printing like batches of finals. So, you know, please be reasonable. If you have questions about it, just ask. I'm happy to give feedback. Someone asked what printing materials would we have options on. For the most part, I print almost exclusively ABS and ASA. So I would expect, or I would say you should expect your final to be in one of those materials. If you need a specific color, maybe DM me and I can see if I have that color. But typically I print them all in the same color. But if there's a specific request for a certain color and I have it, I'll probably do it. Any other questions? If you're wondering if like I could print something out of like PLA or PTG, I actually just like don't have any more, just because I print ABS and ASA like almost exclusively now. But if you need something like TPU or something like really specific, please just ask me because I might have it. I haven't gotten a TPU final yet, but that would be pretty interesting. Any other questions about the final? No?
How long does it usually take you to print everything? Or what's the longest project it took to print?
I mean, like my printer is actually pretty fast. So if you're familiar with like the Bamboo family of products or printers, I built my printer to print faster than them. So on average, I think I print about 30% faster than like most Bamboo machines. So I can usually crank out the finals pretty quickly. I think I was able to print like a whole session's worth of finals in like, 2 or 3 days, including like, me going to class and like printer downtime and stuff. In terms of raw print time, I think I can print almost everything in like 24 hours if the printer like doesn't stop. I don't know if that's the case for a 100 student class, but like for my like 40 student classes, that was the case. Any other questions? Okay. Again, if you have questions, you can definitely ask them later. I'm more than happy to go over. But yeah. Anyways. Okay, now we're actually rendering. So, again, like I was saying earlier, for rendering, it typically results in a very professional looking thing. It makes your part look really nice. It renders shadows and stuff like that with lighting sources, so your part looks, a little bit more real, or just like nicer in general. So we can start doing that real quick. So the first thing you want to do, if you haven't done already, is open Fusion. Which I haven't done, so now I'm gonna have to wait for a second. think my Fusion's updating too, so we're gonna be here for a little minute. Okay, so now that we have Fusion open, basically for this assignment, I'm going to ask that you pick something, some kind of assignment that you did in class. It can be any of the ones that we've done. I highly recommend you pick something that already has appearances, just to save some time. A lot of people do the Lego car, but you can kind of do any one that we've done in class. So what I'm going to do, I'm going to do these building blocks. So you're just going to want to open up the file that you made, in this case, the building blocks for me. I'm going to hide this. Okay, so, let's just say, this is the thing I made, and I want to render it. I'm going to present this to some kind of investor for, this really cool building block company that I'm making, or that I'm the CEO of or something. I don't know. So I have this model. I want to make it look nice and professional before I go in, try to raise some money to this angel investor. I don't know why I'm creating this very random scenario, but you're going to want to go from this design tab or workspace here to the rendering one. So Fusion has a bunch of different workspaces. Generative design is pretty cool, but in this case, we're going to be rendering stuff. So when you enter the rendering workspace, you can see everything changes a little bit. The UI has new buttons. The lighting and stuff has changed. Your part looks kind of different, so that's good. We can still rotate around just like we did before, but now, there's lighting, there's shadows, stuff like that. So, this looks, honestly, this kind of looks worse than it did before, at least in my opinion. So what we're going to want to do is we're going to modify some of the scenery and stuff to make this look a little bit cooler. So if you haven't applied appearances already, you can go to the color wheel and apply appearances. This works, the same as we've been doing for all the other stuff, but there's more or different things you can change as well. The main thing here is the scene settings. So right next to appearances, there's the scene settings tool, and there's a couple things we can change, right? We can change the brightness. I'm just going to leave it alone because I don't want my part to be completely deep fried. You can change the position, or you can move around and stuff like that. You can also change the background, which is the thing that we're going to focus on today. So for some renderings, you just want a neutral background, which you can just have as a solid color. And this might be great for many scenarios, but for the sake of this class, I'm going to ask you to apply an environment. This is mostly just to prove to me you're like, hey, I know how to use this, the scene settings tool and apply an environment. So please change the setting from background, on the background setting, from solid color to environment, and then go into the environment library and pick one of the environments. Again, for this class, I ask that you pick an environment that isn't just one of the generic lighting ones, just because sometimes it's hard for me to tell if you just used a solid color for your background or one of the base lighting ones. So for this class, please use like one of the environments that puts your model in some kind of like real world place. So, there's a couple of them available to you, but you can also add custom ones because there's a couple of resources that I will send for you to apply that, which is extra credit, by the way, hint, hint, if you want extra credit. But basically, you're just going to want to apply one of these environments. I typically just go for the Plaza one when I'm doing this one. So I'm just going to download it and then apply the environment. So you'll see now the background where the parts are have changed. And now you can kind of see the beginnings of, this plaza here. It's very, very blurry, and that's kind of intentional, just so your computer doesn't explode when you try to move around. But because of that, it's kind of hard to tell what we're looking at. So what we can do is we can create an in-canvas render. And what that does is it kind of creates a temporary rendering of whatever thing you're working with to kind of get a better feel for how it's going to look in the end. So to do that, there's this kind of play button with in-canvas render. And when you do this, it's kind of interesting. You can kind of see how your computer will render these objects, right? You'll first start out to be super blurry, and then like each pixel that you get will be divided into more and more pixels until the part looks, until your environment looks super, super crisp and nice. So I'm going to start the in-canvas render. Now you can see, I'm going to close this. You can see the background is a little bit better now, and the model looks a little bit clearer. But you'll also notice every time I rotate around, it gets a lot more blurry. And then, when I let go, it'll slowly get nicer and nicer. And you can also see like this slider here. The longer I wait, the more and more crisp everything becomes. So this is kind of what we're looking for. Messing around a little bit, we can kind of try to position the part in a way that we like. This isn't going to look perfect in some cases just because the environment is just like a very high resolution 2D photo. I'm guessing they use some kind of like 360 camera to create these environments. So, it's not going to look, it may not always look super, super like real. But this kind of gives you a little bit more than just screenshotting your design environment. But once you move around and you're kind of okay with what you're looking at, what we're going to want to do is create a final render. So again, this is just an in-canvas render, so it's temporary, and even though we might wait longer and longer and it's going to get nicer, you don't want to just screenshot this, right? You want to actually render it, and then it'll output a nice image file for you. So I'm going to turn the in-canvas render off, but let's just say I'm satisfied with this perspective here. So I'm going to press stop. And then there's this teapot here. So when we're finished and we want to render it, just hit the teapot. It'll open some settings, and then it'll allow you to render things either locally or on the cloud. So one of the advantages to having an education license is that you have unlimited cloud renders, right? So rendering can be kind of intense on your computer, and if you CAD on a potato like I have for a very long time, when you render things, it'll make your computer sound like you're in an airport. So if you don't want to do that and you want Autodesk to do it for you, you can upload your model to the cloud and have them render it for you. So you can select cloud render. In terms of quality, I usually go for the highest quality, so I just hit final, and then you can just hit render. You can also change stuff like the size, the aspect ratio, and stuff like that. I'm just going to leave it as it is, but then you can just hit render. Autodesk will give you some kind of estimation for the render time. So in this case, it's like 10 minutes. But you can also, render things locally if you want to. But I usually just do the cloud render just to show you that you can. So you just hit render. It'll send your file to Autodesk. And it renders it in the position that you positioned it in your workspace. So I should get a render from this perspective. When you do render it, it'll kind of appear here. Right now, it's still rendering, so I can't view it yet. But what I'm going to ask you all to do for this assignment is that once you get the rendering in, you're going to hit the download button and download the rendering itself, and then I'm going to want you to submit that. A lot of people will do an in-canvas render and then they'll screenshot that. Please don't do that. Some people will open this and then they'll see the preview here and then they'll screenshot that. Please don't do that. Just hit this download button right here and then submit that. Just so you prove to me that you can render things and download things properly. Obviously when you download the rendering, it'll give you the highest resolution possible. And typically when you're working with images, especially for presenting purposes, you want them to be super nice. So, please just download them and submit it. But that's basically it for rendering. It's pretty simple. It's not too bad. In my case, I just have to wait. But that's just kind of it for rendering. So, for this assignment, again, render it, download the rendering once it's finished, and submit it. And then I want 2 renderings, right? So you're rendering whatever you're rendering right now, and then for your final, you're going to submit, your final in the design workspace, but then also your final rendering. So if you're wondering what I'm asking you to submit, because there's a final render and then a final project submission area, that's what you're going to be doing. So there's a render section and then a model section. They're separate. Any questions? No? Because if you don't have any questions, this is basically it for today. Again, if you were on campus, I would usually give a live demo and I would bring my printer into class, but I'm at work right now, so I can't really do that, unfortunately. I will send videos of my printer later, though, for those who are curious. No questions for rendering or the final? Okay, well, in that case, we have basically come to the end of this course, or at least lecture-wise. So if you're here, thank you so much for sticking, with me throughout the past 5 weeks. I know, being on Zoom for 2 hours can sometimes be tiresome, but I'm glad you're all here. If you're watching the recording, hello, thank you for watching the recording. I'm very excited to see what you all come up with for your final projects. Again, if you have any questions, feel free to reach out. But yeah, that's basically it for this week. Thank you so much for joining. And I'll stick around for a little bit, to see if anyone have any questions. But yeah, we're basically done here. So thank you so much.
Thank you.
No problem.
Thank you very much.
No problem.
I had a question. I don't think I've seen a grade come through my email since like the first week. Is it possible?